moving on to product of two binomials. So let's just move that to the side. And here we go. So product of two binomials, as the name suggests, it is where you are multiplying. It is where you are multiplying one binomial by another binomial of two binomials. Here we have ax plus by multiplied by cx plus dy. And these lines are both equal to each other. This is equal to this, thus the answer here is equal to this. And I'm going to explain why the second row is written differently in a second. I just want to clarify. The second row, even though it's equal to the first row, is written differently. It is because you can see here that for bcxy plus adxy, they both have the terms xy multiplied by them. There's an xy here, and there's an xy here. And so we can factor those terms out. And so when we do that, so let's write it out. Again, I'm not in the part of explaining this yet. I'm explaining why these are equal to each other. So bcxy plus adxy. Okay, so we have xy here and xy here. So and when we factor those out, we get xy, because it's shared by both of the terms. Xy is found in both of the terms. So we can get xy, and then rewrite it as bc plus ad, which is what we can see over here. bc plus ad times xy. And so they're equal to each other because when you multiply bc by xy, you get bc xy. When you multiply xy by ad, you get ad xy, which is why this is the same as this. Okay, let's get to explaining how ax plus by multiplied by cx plus dy is equal to acx squared plus bcxy plus adxy plus bdy squared. Again, these are very similar to how we expanded the brackets for sum and difference of same terms and square binomial. So I'm not going to bother rewriting this. I'm sure you understand by now that we would multiply ax by this entire bracket, and we would add and multiply by by this entire bracket. So let's go straight to that. Ax is cx plus dy, and then plus by times cx plus dy. Okay, so again, let's start with multiplying out the brackets. Ax multiplied by cx is equal to acx squared. A and c are unlike terms, so they just remain on their own. But x and x are the same term, so it's a number multiplied by itself, so it's x squared. Okay, moving on, ax multiplied by dy, so that becomes equal to a dx y, and then by times cx is then equal to bcxy, and then by multiplied by dy, then b and d cannot be multiplied by each other, so it's just b times d, but y and y are the same term, so then it becomes, let me just correct this, then it becomes b d then y squared. Okay, and there you go. So that is equal to, so this is equal to this. And if we wanted to, we could factor out the xy from these terms, but it's not necessary. You may be asked to write it a certain way, but usually it's not necessary. And so let's go on to an example of this. Okay, so okay, 3x, that's about 3x plus 2y multiplied by 7x plus 4y. And so by following the special product, we would immediately find that it's equal to, so ACX, in our case, A is equal to C. In our case, B is equal to 2, C is equal to 7, and D is equal to 4. Okay, so A, since our A is equal to 3, I'm just writing it as a bracket for now because we're going to have to multiply A, which is our 3, by 7 because 7 is our C and it is AC x squared, so 7. And then x squared plus, I'm going to move this down a bit. And move this down because there doesn't seem to be much space here. Okay, so we have A times C, which in our case is 3 times 7, plus B times C, which in our case is 2 times 7, because our 2 is equivalent to the B here, and then multiplied by xy, plus ADXY, which will be 3 times 4 xy, okay, plus BDY squared, which is then equal to 2 times 4 dy squared. And so following that, let's just multiply it out. So it's 21 x squared plus 14 xy plus 12 xy plus 8 y squared. Okay, I'll just rewrite this xy. There you go. And we can add this 14 and this 12 together, which would then give us 26. 26. Let's write this here for convenience. And so this would be our final answer using the special product. So let's multiply out these brackets and verify that the special product is correct. 3x times 7x plus 4y multiplied and plus 2 multiplied by 7x plus 4y. Y. Okay? All right, so 3 times 7, that's 21, x, and then 3x times 7x, that's 21, and then x squared, that's itself, 3x times 4y, that is equal to 12xy, because 3 times 4 is 12, and then x and y multiplied together as xy, xy plus 2, sorry, that's supposed to be 2y, there we go, 2y plus 7xy, 2y plus 7x, sorry, 2y plus 7x, which is 2 times 7 is 14, and then xy, and then plus 2y times 4y, which is of course 8y squared, because 2 times 4 is 8, y times y is y squared. Okay, y squared. Right? And you will notice that we have that through our multiplication, it was all the same values as was when we were following the special product. We can see that it's 3 times 7 here, 3 times 7, because that's A times C. Remember, A, B, C, D. A times C, that's 3 and 7, leading to 21. Remember here, special product, A times C, x squared, A times C, x squared. Again, and then we had 3 times 4, which is that's A times D, which we see over here. Remember the order, it's okay if the order of these two are swapped, because the answer is still going to be correct even if it's written as acx squared plus adxy plus bcxy plus bdy squared. That is still correct. Okay, and then we have 14xy, which we recognize from the 2 times 7 here, which was our b and c xy, and then we have our bdy squared. So b and d, it's 2 times 4, and then just y squared. And of course, finishing this by adding 12 and 14, we then get 21x squared plus 26xy plus 8y squared. Okay, so notice how by following the special product of polynomials, we were able to get this correct answer a lot faster. So 21x squared plus 26xy plus, sorry, that was written correctly earlier, plus 8y squared. That's the same as this. There we go. Okay, so that is the product of two binomials.